Okay, so let's get started. So welcome back. This is the final session of ST30, and this is going to be our panel discussion session. The session is being streamed, which is why we've got this slightly unexpected layout of the seats. We didn't manage to move the camera, so this way we've got a reasonable view from the camera and also from the room. And so also because of the streaming, we're going to have to use the microphone, and we've only got one microphone, so we'll have to follow the protocol that you speak if and only if you're holding the microphone. So this should also have a calming effect on the discussion. So we've got three panel members, Stephanie Balzer, Ornela Dardha, and Raymond Hu. We had originally got Luís Caires as a fourth panel member. Luís, unfortunately, is ill with COVID, so has had to miss the workshop, which is very sad. He emailed yesterday to say he'd watched some of the sessions on the stream and he was missing us all. And if you're watching this one, Luís, we've missed you as well. It's such a pity that you can't be here. So what we're going to do is, first of all, I'll ask each panelist to briefly introduce themselves, say who they are, where they're from, maybe what their main work has been. And then the topic for the discussion is future directions for session types. So I'll then invite each panel member to make a brief statement about what they see as future directions for session types. And then we'll open up to questions from the audience. So for each question, all three panelists will have an opportunity to give an answer in some order, not the same order every time. And after the panelists have given their views, we'll open up for further comments or discussion from the audience. And we'll see how we get on. And we've already seen some quite lively discussion after some of the talks in the workshop. So maybe some of those topics will come back in this session, or of course, new topics. And I've got a list as well in case the questions are not coming at a fast rate. So let's start with the introductions. So we'll pass the microphone along for each panelist to introduce themselves, starting with Stephanie.
Okay, hi, I'm Stephanie Balzer. I'm an assistant research professor at Carnegie Mellon University, USA. So I'm interested in one line, verifying concurrent systems. And I'm using session types actually a lot. And I've been employing session types for a few years now. And I think there are so many applications out there that are really very well suited for session types. So I think I will be working on it for much longer.
Hi everyone, I am Ornela Dardha, and I am a senior lecturer or associate professor at University of Glasgow. And I've been in Glasgow for almost 10 years now, so as a postdoc and previously as a lecturer, and I work on session types. My main work that maybe the majority might know me for is the encoding of session types in linear types. And I'm interested in general in expressivity of session types. More recently, I've been working on session types and failures, and I'm interested in understanding the more salient features of large-scale distributed systems and how session types can be used to address those features.
Hi everyone, I'm Raymond Hu. I'm a lecturer at Queen Mary University of London. If you don't recognize me, this might help. So you probably see Nobuko's slide with the back of my head in her. This is the slide that she often shows. So this is me. Yes, I'm at Queen Mary University of London. Until quite recently, my office was next door to Kohei's old office, and it was very nostalgic for me because so I've been working in session types since I was Nobuko's student working with Kohei as well. At the beginning, we were interested in implementations and applications of session types as language extensions, and then later on we were interested in session types without language extensions. Some topics I've been working on recently include session types with refinements, failure handling, and for rate-sensitive systems, which my co-author Grant there would speak more about on Friday if you're still around.
Okay, thank you all three. So let's go in the same order with the opening statements about future directions in session types. So Stephanie first.
Okay, so I think I agree with both Ornela and Raymond that handling failure, so failure handling, I think is a really important topic. And I think it's connected to distribution. So we have many applications today, like cloud computing and so on, that are inherently message passing, but I think many of those are also distributed. And I think with regard to distribution, even though session typing seems to be very well fit for it, I think we haven't really addressed that aspect fully yet. So I think that's important work that has to be done in combination with failure handling. And another thing, maybe someone else will tell me that I'm unaware of some work, but I think module systems for session types is also something that is missing.
So I think I will. This will sound a bit like a project proposal now, but the way I see future direction for session types is in three main areas that are, in no particular order here: theory, implementation, and mechanization. In theory, I think after 30 years of session types, we are now in the position, and recent works have shown this already, that we're ready to integrate relevant salient features like failures or congestion or timeouts and anything of the sort to make the theory closer to reality. The second one, implementation. So if we want session types to be used by programmers in their everyday programming work, then they need to be properly integrated, same amount as data types are in mainstream programming languages. And mechanization, so we don't want to, paper after paper, when we build on previous work to correct bugs of 10 years ago. So mechanization is really important so that the theory is nice and stable. And not only because of that, but once upon a time, the key examples of session types were, well, buying a book, the bookstore, or that for multi-party, or the client-server, the addition example, which are nice examples, but I think we've moved now to more relevant examples like authentication, or I've been looking into embedded systems and self-driving cars. And if in the future we want session types to really be integrated in this system or verify this system, then they better be correct. Because, I mean, we don't want our self-driving cars to actually crash because of the verification, which is far worse than, crashing when buying a book. So that's those are my three main directions.
Okay, so one of the topics I'm interested in is, as we all are, is implementations and applications of session types in practice. And we know session types are challenging because they deal with all of behavior, ownership, and invariance, all the key topics of PL or something. And a good account of session types has us have some account of all of those things in one framework. And so, we have to deal with session types are fundamentally behavioral. It's about evolving behaviors in a concurrent non-deterministic model of computation. And we want to do this in a PL framework, for which purpose we usually have to have some infrastructure for resource, like fine-grained resource control, like linearity or alias control. And then all of this is put together with some kind of compositional invariants like duality or consistency or compatibility or whatever it is that you happen to be using in your system. And that's even before I even mention things like asynchrony and failure handling and all these things. So I think we should give ourselves a pat on the back for being so good at working on all these challenging problems. So whilst I was trying to think of what my vision would be for the future, I was thinking about this, and I realized there's been a lot of very nice works over these years, and I surely myself don't understand all of them perfectly. And I think that's one thing I realized is that maybe myself and as a community, we should try to maybe take stock of where we are and try to understand what we've learned actually in all these different works that we've all been doing, separately, so to speak. What we've learned from that, and how we can use what we've learned to put together this vision of what we might call a success goal for the community in terms of implementation and applications. I mean, we've had so many different approaches, right? Of course, you have implementations of languages from first principles, so it's got an account of all those features that I've mentioned. That's surely session types. But I don't know, maybe that's been the less common approach, actually, especially in the last few years. We have a lot of encoding approaches, encodings into mainstream languages, for whatever that means. And because mainstream languages don't have an account for nearly all of those features that we mentioned, we have to get creative, and we have to do things, find ways to live without maybe all those things. For example, one of the techniques I've used, and I think others have used as well, is looking at session programming in a event-driven context. So event-driven programming, of course, is a major paradigm in practice as well. And it turns out it's very nice because not only is it practical, but you get to do away with channels completely. You just react to events. It's a bit similar to the talk we heard this morning as well. And so that's actually one of the major difficulties of session types in practice, instantly bypass. But if there are no channels, is it session types? That's what I also started to think. I wanted to understand what are all these implementations of session types, and I started to think, well, what is an implementation of session types, and what even is session types in practice? And I think that's something that we can, there's no single right answer, obviously, but something that we can discuss, and that will also inform the kind of directions that we would go to. I'm sorry, am I taking too long? But I mean, as well as encodings, once you start getting creative, you think, okay, if I take out this part and I can live without that part, if we push it to the extreme, is it only the properties that we care about? Is any language, sort of program language style approach that gives you some kind of communication safety or progress, is that session types, And maybe they are implicitly thinking about static properties. But of course, there's been plenty of work on dynamic session types. I'm happy to call it runtime session types, but is it session types actually in that sense? So I think these are all really interesting questions to talk about. And so if we can learn what we have already done, and then we can think of some things that we want to target, and I'm sure we all think similarly. One thing that I remember when I was a student, going all the way back to when I was a master's student, I was doing at Imperial, and I was taking this very nice PL course from Sophia Drossopoulou, and one of the topics she did was ownership types, and that was very nice. And at the time, as a student, I liked learning about it and studying the theory, and she even put it in the exam, and I did quite all right in the exam, so I was happy in the end. Didn't think much about it for a while, but some years later, and then we have things like Rust, right? So again, I'm not a Rust expert, I'm not an ownership types expert, but it's sort of encouraging to see something which at some point was clearly theoretical and research, but it's made it through to the mainstream, so to speak. And maybe we can try to think how, as a community, we could try to approach something like that for session types or behavioral types or one of these things. But for me, it comes back to one of the key challenges is really this linearity thing, right? There's a point where it seems like session types and these things, they're just applications of linear types. And so there seems to be quite a division between, we have lots of theory built on linear type, linear frameworks, but not so many implementations of that. Whereas actually we've had quite a lot of implementations that try to bypass linearity, but maybe not so much theory, let's say, supporting session types and settings without linearity. We've heard some talks in this week maybe going towards that direction. So I think maybe these are some of the directions that we could talk about, and I'm sure people have some good ideas about this.
Right, thank you all three. So let's see who's got a first question from the audience. Hopefully our assistant will help with the microphone. Okay, Cinzia, thank you.
So thank you for your inputs. And this is a kind of provocative question. So you have replied to the question, what could be the future of session types? But do session types have a future? The problem that I see is that I'm taking a look at ETAPS, Confess, and I see less and less of papers talking about session types within the historical form of a process algebra. So how can we make survive our community, since it seems sort of dying, and having seen the future direction, it shouldn't be die. So do you have any ideas? And it shouldn't be die, in my opinion. And sometimes conferences are just a question of style, fashion, and modern topics. But did you analyze the current trends of submissions, and can you see why this is happening and a way out, maybe?
I was going to suggest you first. So.
Yes? Okay. Don't kill me, Ornela. No, that's a very good question. And I have been thinking about it myself, but from another angle. For example, years ago, Concur was the targeted conference for session types, and in general, PyCalculus. And recently, in the recent years, well, there are fewer and fewer papers on session types. But I think that's mainly because they have been promoted to another, they have ascended to another level. So now you find more papers in Popol, Uppsala, Aesop than you used to before. So I think it is mainly a shift rather than a decrease. But now, said that, I don't have the numbers of papers, like how many papers we had 10 years ago on session types and now. So if there is that graph that shows that papers have decreased, then maybe we can discuss it differently. But I haven't had that impression that the number of papers is decreasing, but rather that the venues have shifted and they are going more into PL venues as opposed to theory venues, because the community is also shifting from PyCalculus more to languages. Yeah. Right?
Thank you. Interesting question. Do you have the stats for session types is dying?
It's just a feeling
okay.
saying on participation to recent conferences.
Okay. But I think I agree with Ornela, and I think we've seen several talks this weekend. Frank also explicitly mentioned in his talk. Besides PyCalculus, there's quite a lot of session type frameworks set in, more, let's say, practical languages, functional languages. There's been work in object-oriented languages. And trying to use techniques that, sorry to mention it again, but I think the linearity thing is something that is very important, right? And so maybe that gives us two broad directions. One is we have things like Rust, which is a mainstream language with some powerful accounts of resource control. And so maybe we could start to, and we know that once you have that, you can have things like session types and type states and things like that. They're much more accessible in that framework, right? So one option might be to think of languages adding that kind of facility to other languages as well. And the other is, as I mentioned, trying to look at practical language settings that can try to find some way to address that linearity issue for channels or whatever it is that you're reasoning about in some practical way. Yeah.
I think it's an interesting question. I tend to agree with you. However, I'm not sure whether the numbers are declining, but also the community, the session type community is quite representative. And maybe from that perspective, maybe we're not so well represented at those PL conferences like POPL, ICFP, ESOP, and so on. But I don't know. I mean, my view would only be subjective as well, and also submitting myself and serving on PCs. However, what I notice is that, and I think maybe that's the problem, that there seems to be like a divide between like people who are very familiar with like natural deduction lambda calculus and people who are familiar with process calculi, sequence calculi, session types. And only a few people can do both. And I think like at conferences like POPL, ESOP, and so on, so more PL conferences, I see that more people fall into the former. So they know really natural deduction, lambda calculus. And I infer that from questions that I get when I'm submitting or where I also like co-review papers. And maybe a reason for that is like a programming language class taught at, I'm no longer familiar really with the European system, but like take TAPL, types and programming languages. So it focuses really on lambda calculus. So maybe that is something that could be changed in the educational system so that people get exposure to both paradigms. And I think that would actually help us. Because I really get sometimes feedback where I get criticized for my heavy notation from outsiders, which doesn't really make sense.
Thank you. So any comments from the audience? Maybe anyone who's been on a PC chair recently or something, or might have comments about submissions on session types? I think, Marco, were you raising a...
Another question.
Well, a comment on this.
No.
Right. Then for the next question, then. Okay. Right. Well, let's go to the next question, which seems to be from Marco. Oh, sorry. No. Yes. Sorry. Antonio is reminding me that he had put his hand up earlier, and it was so long ago that I forgot. So let's go to Antonio first and put Marco in the queue.
So the question/comment is that on the implementation side, and so ownership types, they came to solve a very urgent problem, memory and safety, right? That was a really pressing problem, and putting the compiler taking care of memory and safety was clearly important, right? Now, what we are providing is less clearly a crisis, right? We don't have the $1 billion mistake problem. So I think we need to show that there is a way of, in an easier way, getting programs correct. And for that, we also need help from software engineering people. Because I don't know how to do an evaluation on what you gain with my approach to use behavioral types in programming languages. So I'm convinced this brings something. I'm convinced this brings better software and you get correctness by construction and by the compiler, but are we actually offering to the world a gain, a concrete gain? For that, we need proper studies from people that know how to do them. Right.
Okay, would anyone in the panel like to comment on that?
I agree. So when again, I'm not a Rust programmer, but as I understand, it's dealing with the ownership and resource control, and it's something, I don't know, it's the best word for it, pervasive in the language. It's something that's been controlled in every variable access or assignment, or every argument that gets passed in a call and things that get returned from a call. It's very pervasive. Whereas if we look at distributed systems, something that involves a a reasonable amount of communication, if you just look at it in terms of something simple like the number of lines of code or something, the amount of code that's actually I/O specific is probably relatively small compared to perhaps the size of the whole project. So it doesn't session. So if you think of session types as just types for protocols on channels, very specifically like this, that is traditionally formulated, it doesn't have that same kind of pervasiveness. But perhaps that's what we need to do is try to think what we might fundamentally extract from what we've learned from session types and these kinds of approaches in this PL setting. And personally, I think something like type states is something which is a bit more pervasive than just the specific I/O instance of that. But I suppose what type states lack and session types have is the accounts of composability, I suppose. But I'm sure that people who know type states better than me might be able to point to some works in this area. But yeah, perhaps we can try to think what have we learned from session types in that regard, and how to really build a language around what we've learned from that isn't necessarily just about channels and explicit typing of channels.
Okay, thank you. So I think let's now go to Marco, which I think was a next question. Is that right, or is it a further comment? The next question.
Okay, so my question is a bit of a stretch. One thing that I'm thinking about the hype of the moment, which is statistics, machine learning, these kind of things. And does any of you see any connection from what this community is doing towards that direction?
Wow, that's a big question. Surely CMU is full of people doing machine learning like everywhere else.
Well, that's in another department. So we have 7 departments in the school. So I don't know. It's a really good question, but I think it's really a hype. So, and I think it's blown out of proportion. And people who don't know anything talk the most about it. So that's the problem. So what I think what we can do as a PL community is to target verification, because all those, to my knowledge, all the software generated by AI is, I'd rather have a human actually implement a flight controller than an AI agent, or like a neural network. So I think it's probably something that we should look into, and how we can together basically meaningfully contribute to that area, but I haven't thought about it. That's my comment. So it would be an opportunity, I guess.
That's something that I've been trying to somehow to fit together, because I was curious as well. Is there something that can link session types to machine learning or AI? And I don't have an answer yet. But when I've spoken to people who are expert in AI, every time I explain session types, then they say, oh, and then you can use ML for this and yada, yada, yada. A lot of terms that I don't get because they are specialized. So it seems that there might be something, but I haven't figured it out yet. But it is interesting. And I think there are maybe projects that will be proposed soon, hopefully, that will link the two areas. So fingers crossed.
So I'm not a machine learning person, but maybe one area that I may have seen that might be relevant is to do with inference of protocols. So maybe not just inference, like type inference from a language, but also possibly from inference from a set of traces or runtime logs or something like this. So again, I'm sure that people here are much more expert than me. But if you if you have a set of traces sort of inferring the automaton that accepts those traces, it's very easy to be overly naive, right? You can always just construct something very directly, but that might not be morally the protocol that you might want, and there may be some possible applications of using some heuristic techniques, which, I don't know, machine learning might be one possibility to go into this, to try to infer more realistic protocols from these things, for some meaning of realistic.
Thank you. Does anyone in the audience have any comment about machine learning or AI and session types? Nobuko, yeah.
So there are two of areas we can link easily for AI. One is, for example, concurrent robotics, and I once studied with MPI people, and another area is, of course, multi-agent. This is quite easy to, because anyway, we are doing actors. Another thing, I'm not a specialist about it, but several actually people in this room has a European grant, TARDIS, and with other people is actually working on federate learning, and they try to use a global type to model it. So if we success this deliverable, we have some real connection with distributed learning. But we will see. Actually, I'm not really specialist, so but that would be. I think it's possible to just looking around. But I don't know Glasgow team is submitting some grant proposal. So I actually want to know more about.
Okay, thank you. So let's, I think one topic that came up in one of the sessions yesterday was about mechanization and the whole area of mechanization. And I think Felix had framed this question in quite an interesting way. And maybe he would like to restate his question, and then we can have a little bit more time than we had yesterday to discuss it. So if that's okay, Felix, we can get you to put your question.
So the actual question I had yesterday was how much more overhead actually use a theory improver session. And the reason why I was asking is I explained a bit yesterday in the a number of bugs transition, a call for transition to mechanized proofs, obviously. Quite a lot of effort, obviously, as like an initial framework. Then from the community, it was expected to kind of pick up from there, right? Then I also know, and I think you probably also know separation logic with Iris, the framework that Derek Dreyer has proposed. And then there, this was really picked up a lot. And I've heard about stories where people could not basically publish papers anymore, where there was no mechanization, even though they might have had new insights. Maybe because the foundation was not like matching what Iris provided, but redoing all of the foundation would not have been feasible to actually just one publication. So now I think the question for this panel, which is more interesting, is how do you see a transition towards like all mechanization, like that people, like everybody will mechanize things, and how does this affect the number of publications also compared to like these hype topics like ML and like machine learning and artificial intelligence? And okay, and so I missed one point for this part of the added overhead. I think, for example, that our calf paper would not have been possible if we were required to mechanize all these proofs. Like this required, I think, probably 200 to 300% of the effort that we already put into it. And I've did masters in like Koch theorem proving everything. So yeah, that's my estimation.
Okay, so how will it happen? Well, I think slowly, and in different amounts. So often what happens now is that the theory comes first and mechanization comes maybe as an afterthought. So sometimes that's, well, almost double the work. And as such, people are discouraged and just happy with pen and paper proofs. Then when it comes to mechanization per se, up to a few years ago, it didn't seem it added much for different reasons. First, I think we are more fed up now with bugs than we were back then, finding bugs in previous papers, and it's yet another subject reduction that maybe doesn't work. So it feels more urgent now than it did. And also, didn't seem that you could find appropriate venues to go for. Right now you have CPP, ITP that are on theorem provers, so it is more mainstream than it used to be. If instead the work is in parallel, or you are thinking of your paper in the mindset of, okay, this will be mechanized, then I would expect, as I've done with some of my PhD students, that the time that it takes is, of course, less. Maybe not same amount as it would take on pen and paper, but you have added value for that added time. So I would expect that in the future, then maybe a paper will be conceived with the proof checking in mind, as opposed to doing it afterwards. And Jules is not here, so he did it as part of his PhD, has 7 publications, all of which are mechanized, so it is possible.
Okay, so I wanted to add to that as well. Actually, Jules is Robert Krebers and my student that we've been jointly co-supervising, and almost all of the 7, but not all, not everyone. I think the probabilistic programming one is not mechanized. I don't know. So I think, so what I kind of see from the work that I've been doing is, so we started mechanizing meta theory of session type languages. So we have, and not only session types, we also have, like at this year's POPL, we had a paper on a type system with higher order locks. So a lambda calculus based type system. And so what happens is, so there we've been very successful with publishing. Also, I should notice, which is maybe interesting, that the session typed works all are embedded in a lambda calculus. I think that made it more friendly to the POPL audience. So for that work, it took us about a year to build basically we have a connectivity graph library in Koch that allows us to reason about acyclic graphs. And so we took about a year to build that infrastructure and then have the first result. But then we could build on that infrastructure, and actually 2 more papers came out of this. So I think you can do some bootstrapping work and then build on it and still be successful publishing. But then on the other hand, like the meta theory has already been in place, right? We know how to reason about deadlock freedom, memory leak freedom using linear type systems. So we were basically building on all the prior work of people doing this kind of works with using pen and paper proofs. So on the other hand, right now, I've been working on logical relations for session type concurrent systems for the past, I think 4 years now. That's, I think, when I started. And we're now starting mechanizations of all those results. But clearly, we could not have done, we can't use IRIS because IRIS, I think we have a different perspective of things, and it will be actually interesting to explore what that means in terms of mechanization. So I think my I guess summary of what I'm saying here, the conclusion is, I think you have to strategize. So focus on some work that is mechanizable, like maybe with 1 year's effort, and then you can build on it. But then on the other hand, there will be work that takes more. That takes probably 2 years until you can start building on it. But that being said, like there is some work, like the logical relation work that we've been doing so far. Now we are at the point where I don't want to touch the proof anymore, because it's like 60 pages or 70 pages LaTeX. So it's no longer scalable. And if I want to do the next steps, I'd rather have a mechanization.
Thank you. Ray, do you want to comment?
Thanks. I probably don't have much to add. I suppose I'm on the side of the camp that needs to be persuaded to do more mechanization. I think the talks that we saw yesterday from, for example, Marco and Lorenzo were very helpful in that regard. For somebody like me, it will be very helpful to understand better, to have very simple explanations of what specifically about session types is the issues related to mechanization, as opposed to just more general PL mechanizations and things like that. And I look forward to when Lorenzo has finished this framework and we can all just use it with minimum effort and it all just works perfectly. And so.
Can I add something? I wanted to add to a comment that you made, Felix, about how did you phrase it? Like, what about like the foundational work that is necessary so that we can all then start mechanizing things in the future? And I think that foundational work is really, really important. And that foundational work has it much harder, that's my subjective impression, to get accepted at conferences. Precisely because you have done those comments, oh, but it's said that your proofs are only pen and paper, rather than being mechanized. But I think it's important to give space to work that kind of bootstrap future work that then can be mechanized. It's feasible to do that mechanization effort. But in the beginning, it's not. I mean, even doing the pen and paper proofs in a very detailed fashion take a lot of time. Yeah.
Thank you. So it seems to me that what Stephanie in particular said is quite consistent with the idea of having a research program rather than just thinking in terms of particular papers. And I think that's a good strategy in any case. If you're, over a longer term. Now, it may be that within the context of a PhD, it might be less easy to have a long-term research program in that sense. So there are some hands going up. I would quite like to hear in a moment from Brigitte on this one, but you can compose yourself while we go to the people who were signaling for comments. So I think I saw Marco and Jorge. So let's go to Jorge first.
Thank you. So I have a question for everybody, actually. So one thing of thinking about the future of our community is, of course, publishing and how we manage to move collectively towards publishing. Another way of thinking about future is funding. So, of course, everybody has a different view of funding. And in the Netherlands, we have this very peculiar situation in which there is no funding, right? And not only that, the idea of formal methods being already embedded so intrinsically in all departments that there is no longer need for a formal methods subunit, for instance, in CWI, right? So, my question is, how do you see the perspective of session types in the future, also in the context of funding? How do you convince other people, like these panels that come from different sciences and different disciplines? How do you pitch the idea of session types in that context? I think it's a much harder and a different kind of problem than publishing and so on.
So let's put that on the stack for a moment. I sort of misinterpreted your signal because I wanted to stay on the mechanization for a moment. Well, we're going to finish at 5:30, if I'm not mistaken. I think all the sessions are 1.5 hours. So Brigitte, are you willing to say something about mechanization in general and perhaps as applied to session types?
So I guess I want to pick up on your comment that what is different, I guess, for session types versus other PL systems, and why has it been fairly successful in the popular community to mechanize parts of the papers, at least. I don't think it's 100% of the papers that have been mechanized. So I think there's always room for papers that are not mechanized, but I do think it's become sort of more common that PhD students also mechanize at least part of their work if it's in the non-session type world, in the functional world. Okay. And part of this is, I think, that there was sort of a learning curve that people have sort of settled on what they think is sort of a successful way of doing it in systems like COC or ACTA. And I think the most common way of doing it is at the moment is well-scoped de Bruijn indices, which is sort of a good middle ground for ensuring that the terms you work with are well-scoped, and but you get certain infrastructure. But it has taken a really long time to get there, right? Like, I mean, if you think back in the 90s, there was a lot of people trying various kinds of dependent type encodings, locally nameless, higher obstacle syntax, and how far we can push these kind of things. And so I think part of it is understanding, what in this design space, in this open world that you have in systems like COC, what is the path you should take? Okay, and so that's partly experience, but it's also partly sort of learning from systems like high order abstract syntax. What are good ways of thinking about these kind of things? And in the session types world, there really is sort of for me, there are sort of two challenges. One is that you have this notion of linearity, which is really we haven't dealt with in the past before. And that has all kinds of implications on where things are bound and how you manage your assumptions. But the other challenge is that it comes from, that it's much easier to mechanize something that comes from a logical foundation. So if you look at Frank and Louis Caires' work, or the classical process calculus from Phil Wadler, then there we see more clearly where things are bound and how the context is managed and so on. And so part of it is maybe that the community, the two sides need to grow a bit more together. Okay, the logical side on the one hand, and things that are inspired by multi-party session types and other formulations of session types, which might not lend themselves directly to mechanizations as elegantly at the moment. And so the bar becomes quite high in order to mechanize them. And therefore also take a lot of time, right? But I think in general, it's part of it is it's a learning experience of how we design these systems, and then also building infrastructure. I think what Stephanie has been saying, I think that is maybe reusable also in other settings. But I think it's a really exciting way to think about how we can evolve these systems, because I think it's not only mechanization as a means end, right? It kind of gives us something back, and I think both Ornela and Stephanie have commented on this. So I think it's valuable because it also clarifies our own minds, right?
Good comment. Thank you very much.
So thank you. I mean, I know we have other enthusiastic mechanizers in the audience. Would anyone else like to comment about their experiences of mechanizing theories of session types? Okay, Lorenzo, thank you.
So yesterday I presented this concurrent mechanization benchmark, and I got your question, right? And today it was repeated. I think that, of course, the panel and Brigitte has answered better than I could. They are more experienced for sure. But I have my small experience in mechanizing either traditional PL concepts and then multi-party session types. What I have seen and why I think projects like ours have value is that the two things, so both the session types, but also the mechanization community and the mechanization support, so proof assistants themselves, need to grow. That's why in one of my last slides, and I'm sorry if it wasn't clear because it was prepared last minute, and I apologize for that, but it was the concept of both community benefiting by them. So the support that proof assistants offer now is somehow still at an early stage. If you don't accept this comment, accept this other one where much more can be done for them. And in my experience, that I have experienced both in Isabel and in Koch, this is definitely true. I mean, this is 30 years of session types, and Ray was pointing out that session types are not well integrated in programming languages yet. Proof assistants are not considered mainstream programming languages yet. They are younger. And yes, so this thing of the need of growing also of proof assistants to get to a better support and more easier mechanizations is there. Therefore, and Brigitte said it perfectly, but there's something, if they grow and we start using it, we get something back. And that was my comment, again, in the talk, about the additional knowledge we get from them. So, yeah, so substantially, I agree, and I think that there's a lot of space for good evolution.
Well, let's give Felix a final comment. Yeah, thanks. No, I will not settle this, but okay. Thanks a lot for your comments. As I phrased yesterday, the question, it was like on purpose a bit provocative, and I'm actually by no means against mechanization. Like with my background, I see the value. I just wanted to see how you imagine this future towards a transition towards actually everybody mechanizing. And I think that's an important matter to discuss because it's important for the community also in terms of growing and publishing. Thanks.
Is it a comment about mechanization or a new question?
Me? Yeah, it was still about this question.
So I don't have anything to say. So
Shall I, or?
Okay, very final mechanization.
I think I'm a bit surprised so thank you for Brigitte and Lorenzo, who explained how we can get something back from the mechanization. I'm no expert on mechanization at all, but I think they simply shouldn't be opposed. They are both essential. I mean, mechanization and fundamental theoretical work. And I don't agree at all with you, Ornela, when you say I'm fed up with finding bugs in pen and paper papers. I think if you find more bugs, it's because we take less time to write these pen and paper papers. Because we are pushed, we are sort of drawn into this accelerated rhythm of publication. We try to compete with communities which have nothing to do with us, like machine learning and artificial intelligence or whatnot, vision, computer vision. We just shouldn't compare with them. I mean, we are different communities. We know very well that all these impact factors depend on the size of the community. They depend on the publication practices. They are badly affecting our publication practices. And I think we should keep in mind that what matters is sort of setting an interesting problem and trying to solve it in the long run if needed, and not trying to compare. I mean, it shouldn't be, unfortunately, it has become, but it shouldn't be the goal of a young, early researcher to have a career plan to publish that many papers, but to get passionate about a problem and have the time to. So I'm a bit
somehow I'm a bit disappointed to see this. It shouldn't become a dogma that we should mechanize everything to trust the results. I don't believe that at all. I mean, once upon a time, nothing was mechanized, and the papers didn't have that many errors. And even if you find a mistake in a theoretical paper, that mistake, I mean, it can be useful to find a mistake and progress on I don't see it as research is full of negative results as well, or of, I don't know, that Gavin Law famous security protocol that was broken while, all the CSP community was quite confident about it. So these things happen, they are part of research. I don't see them as dramatic. Of course, if they are used for cyber in critical systems, okay, that's different, but this is not the kind of theoretical results which are targeted. So anyhow, I just want to say that I wouldn't be so pessimistic, and I wouldn't oppose the two.
Okay, so Ornela wants to reply, and then I think we'll move on to the Jorge's question, so we have time to cover some other topics. So we can respond to that.
So I don't think in any way I mentioned that the bugs are due to the fact that we're hurrying to publish. So I myself worked on a paper, spent a lot of time on it thoroughly. It got accepted to a conference, and just right before the camera ready, there was a bug in the proofs, and we withdrew it. And it took us a year more of work to make it better and actually publish it to a better venue. So it is exactly that moment that I myself thought, okay, I need a better strategy than this. And it wasn't because I was rushing to publish, because the paper got accepted and we withdrew it from the conference. We didn't publish it. So it doesn't mean that the bugs are a result of rushing and the competition and this vibe, everything you said. I think they are more related to what Marco mentioned yesterday. They are pen and paper, and sometimes you have 60 pages of proofs, and it happens because it's a human error. So that's the thing. So I don't see why then opting for something that would give you guarantees that they are correct shouldn't be the goal. That's the first. The second, what you're saying is that, well, it might matter, these errors might matter in cybersecurity and whatnot. And I mentioned this in my intro, that once upon a time we were talking about bookstore and addition mathematical server. But we might want to have session types in systems, embedded systems, real-time systems. You might have in the future examples of self-driving cars or the verification of plane software. So in those cases, then you better have the results correct. So it matters more than it did before. That's what I mean. Yeah.
Okay. Thank you. I mean, clearly there would be scope for more discussion about this, but I think we can move to another topic, and maybe we can get a couple of topics in before the end of the afternoon. So we've got Jorge's question on the stack, which was briefly, what do we think would be good strategies for getting funding for continued research in session types? So let's go to Ray first on this one, because he was last on the last one.
So, well, from my own background, I guess I'm biased. I have an interest in implementations and applications. To be honest, I'm not really sure to answer the great question. I suppose if we can find some of these bugs that have occurred, ones that hit the big news or something like this, if we can demonstrate just how, I forget who it was who was mentioning it just before, if we can demonstrate just how serious faults in software, communication-based software, and these things can be. That's clearly a good motivation for the correctness of this software. And just on the spot, I don't have the best examples, but I know in some last few years, there were various incidents in the UK with the various financial institutions and causing, however many, financial losses due to some software errors and things like that. So this is probably one thing that has real-world impact, I guess. Bugs, faults, errors, disasters, I suppose. And then, of course, after pointing out all these potential disasters, we have to find some stories that we can come up with to how we would prevent these and deal with these. And
do you want to go first? I can after you. Okay. So a short answer: collaborate out of your comfort zone. So collaborate with people who you have maybe an intersection. You want to have an intersection in terms of topics, but also, of course, on the human level. That's more important almost. And then learn from them, and they learn from you. And I think this is nice how you find new applications of maybe tools that you're using now, or tools you can further develop. That would be my advice. Just get exposure with other, like, for example, I'm now working with someone who is really more a real-time system person, and that has helped me tremendously. And I think has helped us both, so.
Okay, so on funding, as a PI, I have 100% success rate of funding, but that's only one. So I submitted one, I got it, so maybe I'm not really the best person to answer. But the way I approach that, and definitely it's the way I will approach all future proposals, is when it comes to funding, the question is, the funding bodies are giving you money for what? And that's for addressing economic, societal problems. And are session types, then you can turn the question, are session types able to address any of these problems? And I would say, as we all know, absolutely yes. So from the moment that the whole society is built on distributed systems, then definitely we can cover that with session types. But it relates very much to what Ray was saying, that you need to, and that's where the proposal will come, you need to integrate then into your theory and development and whatnot, what the real systems then are bringing, which are failures, congestions, timeouts, and so on.
Okay, thank you. Those sounded like good points. So, hey, Hans, is this a new question or a further comment?
It's probably further comment.
Okay.
I'm just wondering if there aren't really two questions that are being, I wouldn't say confused, but being merged here. That one is how do you live within the current landscape of funding? And that's what Stephanie's addressing. But another question is how do you change landscape? And I think if we're talking about the future of session types, we should probably address that other question more directly.
Okay, so that was good food for thought, Hans, in terms of building our networks to try to influence future funding calls and the directions that funders are interested in. So there was. Do you have a new question?
Well, maybe a short comment. So I think there is an opportunity to bring session types more into the mainstream, because there's several people in the Rust community who want to add linear types to Rust, but they just need more ammunition for it to convince the rest of the community. And I think session types could provide that ammunition. And if that happens, then people could start using session types in their Rust programs. So I think that would be very nice.
Yeah, I wanted to follow up on that briefly. I think that's really true. And so we actually had, Frank and I, an ongoing collaboration with people of the server team at Mozilla Research. And they already explored session types on their own because they use all message passing concurrency. So server is a highly parallel browser engine. And so because of their interest, we started collaborating. And out of it came a session type library in Rust or EDSL, Ferrite. And sadly, Mozilla then restructured and the whole server team got fired. So, so for us, that's sad because I would have hoped that they maybe could use it. But I think I agree. I think there's interest, and I mean, server survived in other forms.
Yes. Okay, do we have any new topic? Which might be the last topic, depending on the length of answers and comments. Nobuko, a new topic?
So apart from mechanization, many people are interested in PL committee testing. And Martin talked about benchmark, but there is another way to test, of course. You can take benchmark and then sometimes you have many benchmark. It is like testing, so that instead of mechanization, and it's similarly model checking, we can do more like, your theory is correct by checking by model checking. Then we find out the bug of the theory from model checking. Like this, is there any more, because big distributed implementation, you cannot mechanize whether you implement correctly. So theory can be mechanized, but real implementation is very difficult. Large scale, it's very difficult to implement, mechanized. So probably there is another way to also test your theory or your implementation using more developing testing approach. And I'm not sure this community to think about more testing approach. And is there any people study testing and session types or implementations and more like benchmark?
So I haven't done work on that specifically, but of course what you're saying is absolutely interesting. I think there's two interesting points that you said there amongst many things. One is testing, and given protocols, of course, as we know, the only way distributed systems work is because protocols already exist. What session types bring is some level of formality to this, right? And with a protocol as a formal artifact, it opens up a lot of opportunities. For example, test generation, automated test generation, mock generation, stub generation, all these sorts of things which are very important to practical software development methodologies. Of course, monitor generation or full runtime verification generation you could even do. Another thing that's interesting in what you said is now I have to think what was the other thing that you said. Give me a second. Yes, exactly. So I think maybe in particular with the implementations of multi-party session types, we sort of drifted away from the types. I mean, it's session types, but in some works, we got less and less interested in the type system. We have multi-party papers where there isn't even a type system. It's the most boring part of the whole thing. So for the multi-party system, sort of we often, quite a lot of papers often have a global types and a local types and some kind of correspondence between them, preservation of fidelities or whatever it is you want to show between globals and locals. And that seems to be the hard part of checking whether your protocol is good or not in the first place. Assuming your protocol is good, sort of And again, with the caveat of the whole linearity issue, but if you have something like that or some way to get around that, just making your process, checking whether your process follows that structure doesn't seem such a big deal in practice, actually, a lot of the time. And so, yeah, what you say is very interesting because, again, it sort of goes back to what is session types? What is an implementation of session types? Just you have your protocol specified in some way, totally statically offline verified by your favorite off-the-shelf verifier for concurrent systems, whatever it is, totally unrelated to session types. You know your protocol is good, and then after that, you just need to make sure your processes follow the parts in that protocol. Is it session types? I'd like to hear what everyone thinks about that.
Do you have anything to? Well, you have the opportunity. Well, if Ornela or Stephanie want to comment on that topic, please do.
I think the main reason for mechanization having had so much focus so far is because the focus on session types has been a lot on the theory. Hence, we need to make sure that the meta theory of session types is correct. When it comes to implementation, what you rightfully said is that if you're implementing, well, a full language, then mechanizing is going to be difficult because of the size. And I think testing hasn't taken off because, well, we haven't even reached that stage with session types, that our implementations so far have been small prototype tools, and yeah, we've done maybe some testing, benchmarking in those tools. But the need for real testing, as you'd see in PL, hasn't arisen because session types haven't become mainstream yet. So I'm wondering if, so it might be a speculation, this one, that when that time comes that they will become mainstream, then maybe testing will come together with it as a necessity to make sure that they are implemented correctly.
So I saw hands up from both Jorge and Antonio. So were these new topics or further comments? Okay, Antonio had a further comment on testing then.
I think that there is another use for testing that is to address a very, very old problem, is that does our formal specification actually capture what we want it to say? And so we sometimes devise tests like runs, just say, this should not happen, right? And now, is my formal specification allowing this? Because if it is, it's not what I want. So testing as a way of validating that we capture correctly, because then we have the multi-party session type, let's say, and then the program actually follows it. But if the specification is allowing something that intuitively the client that told us do that specification does not want it to do, then it's wrong, right? So testing can also be this way of having like use stories or use cases just to make sure you actually captured what you're supposed to.
Well, Jorge said he had another comment.
Okay, yeah, let's give the mic to
Well, I don't know anything about testing, but I know that testing is the reality in software engineering. So I think it's a very good point that that this somehow should be connected, right? So my point was actually a bit about testing, but also in the spirit of mechanization. So something that we have done in my group, mainly because we are not experts in mechanization, is to go to something that could be labeled as lightweight mechanization, and it's this idea of using this tool called mod in order to formalize and to write the theories of session types into that level, and then you can have a way of a kind of of finding certain bugs in your formalizations at a relatively low effort. And I think this is a good interesting thing because it's not really as heavy in terms of load, in terms of like going directly to code. It also allows you to test your specifications or your theories to some extent, right? So if there is something that is evidently very subtle, you can already try to catch some of these things. So some of the first experiments that we have done is have to do with formalizing, for instance, the type checking algorithm that Vasco formulated in the fundamentals of session types, right? So we managed to actually implement things completely. So I think this is actually a halfway between going full mechanization, which is costly, which requires a number of years, talented people, and money, and something that allows you actually to get some trust, because indeed the main issue is trust, right? And testing also is part of that picture, because with those tools, with those rewriting frameworks, actually you can do a bit of testing also of your specifications.
So I think that brings us pretty well up to time, and so we should bring things to a close. So first of all, thank you to our panel members, Stephanie, Ornela, and Ray, for their insightful contributions to the discussion, and thank you all for the questions and for the further discussion. In addition to the panelists' comments. And so finally, this brings the workshop to a close. So let me finish by thanking all of you for coming and participating, and the speakers for contributing their talks, and also, of course, Diana for co-chairing, and our assistants who've been in the room helping whenever we needed them, and the programme committee members, and also the other members of the organising committee. So we hope you've all enjoyed the workshop, and I look forward to seeing you all again at whatever the next meeting is that brings us together. So thank you, everyone.
Simon, you didn't tell yourself.
We can. I'm not very sure where. I mean, the only website is within the Splash website, so I'm not exactly sure where we would put slides. The authors can attach them to their own talk information. Okay. So if you wish, you can put your slides in the information with your talk. Yep. Okay. Thank you for all your help.